day to all. Today we will be discussing the limit laws on evaluating limits of algebraic functions. Now let us discuss the different parts of a radical. The radicand is the value inside the radical symbol, or the value you want to take the root of. In our equation, the radicand is x minus 4. Now, what is the index? The index tells you what root is being taken. In our example, cube or 3 is our index. Let us discuss limit. A limit is the value that the output of a function approaches as the input of the function approaches a given value. In formulas, a limit of a function is usually written as limit of f of x when x approaches c is equals to L. Now let us move on to limits with radical function. When evaluating a limit involving a radical function, use direct substitution to see if the limit can be evaluated whenever possible. If not, other methods to evaluate the limits need to be explored. Take the following for example. We are given the equation of f of x is equals to square root of x minus 3. Now, we need to find the limitation of x when the value reaches 9, square root of x minus 3. Our equation will become limit of x when the value approaches 9, square root of x minus 3 is equal to limitation of x when the value reaches 9, square root of x minus limitation of x when the value reaches 9 times 3. And when simplified, our equation becomes square root of 9 minus 3 is equals to 0. Therefore, limits of x when the value reaches 9, square root of x minus 3 is equals to 0, which could have been determined by directly evaluating f of x at x is equals to 9, i.e. by using direct substitution. Now, find the limits of x when the value approaches infinity, square root of x minus 3. Evaluating f of x at ever-increasing positive values of x shows that f of x increases without bound. Therefore, limits of x when the value approaches infinity, square root of x minus 3 is equals to infinity. In both of the following examples, direct substitution can be used to evaluate the limits, and there is no need for alternative methods. Another example is finding the limit of x when the value approaches 7, square root of x plus 2 minus 3 over x minus 7. Our equation will become square root of x plus 2 minus 3 over x minus 7. Now, we substitute the 7 to all of the x. That will become square root of 7 plus 2 minus 3 over 7 minus 7. Then we simplify to 3 minus 3 over 7 minus 7, and that will become 0 over 0 or 0. In our next example, we have to do something to our equation in order to change it. The key things to spot are that there's a radical and two terms in the numerator. A common trick is when we have a radical is to multiply by the conjugate. Let's try multiplying the top and bottom by the conjugate of the numerator. In our equation, limit of x when the value approaches 7, square root of x plus 2 minus 3 over x minus 7. We then multiply it to its conjugate, which is square root of x plus 2 plus 3 over square root of x plus 2 plus 3. When multiplied, it results to x plus 2 minus 9 over x minus 7 times square root of x plus 2 plus 3, which becomes x minus 7 over x minus 7 times square root of x plus 2 plus 3. We then apply the cancellation method. We'll now have its simple form. Limit of x as it approaches 7, 1 over square root of x plus 2 plus 3. Then we will substitute 7, which will give us the equation of 1 over square root of 7 plus 2 plus 3, which will become 1 over 3 plus 3, or 1 over 6. Therefore, the limit of x as it approaches 7, square root of x plus 2 minus 3 over x minus 7 is equals to 1 over 6. Let us try another example. In this problem, we will find the limitation of x as it approaches 0, square root of x plus 4 minus 2 over x. Using direct substitution to find the limit of the function results in the indeterminate form 0 over 0. To transform the radical expression to a better form, do the following. Multiply your equation with its conjugate, square root of x plus 4 plus 2 over square root of x plus 4 plus 2. Our equation then becomes x plus 4 minus 4 over x times square root of x plus 4 plus 2. And after the use of substitution, you will get x over x times square root of x plus 4 plus 2. And when simplified, this becomes the limit of x when the value is 0, 1 over square root of x plus 4 plus 2, which is equal to 1 over 4. Therefore, the limit of x as it approaches 0, square root of x plus 4 minus 2 over x is equals to 1 over 4. Shall move on to another example. Using direct substitution to find the limit results in the indeterminate form 0 over 0. In order to evaluate the limit, we need to transform the expression to remove the indeterminate form. This is accomplished by using the relationship for the difference of squares of real numbers, which is x2 minus y2 is equals to x plus y times x minus y. We then rewrite and simplify the original form of the function as follows. Let's take the function h of x is equals to square root of x minus 3 over x minus 9. Then, let us find the limit of h of x as x approaches 9. We will then apply our difference of squares to our equation, which will turn it to limits of x as it approaches 9, square root of x minus 3 over square root of x minus 3 times square root of x plus 3. After which, we will use the cancellation method, and it will give us 1 over square root of x plus 3. And when simplified, this becomes 1 over limitation of x as it approaches 9, square root of 9 plus 3. Then it becomes 1 over 6. Therefore, limits of x as it approaches 9, square root of x minus 3 over x minus 9 is equals to 1 over 6. Things to remember. There are many problems that will involve taking the nth root of a variable expression, so it is natural that there may be sometimes a need to find the limits of the function involving radical expressions using square or cube roots or any other root. And also, when evaluating a limit involving a radical function, use direct substitution to see if a limit can be evaluated whenever possible. If not, other methods to evaluate the limit need to be explored. Thank you for watching our video. We hope that you've learned something from this video. Follow our Facebook page for more content, and if you haven't yet, subscribe to our YouTube channel. Thank you.